Hey, welcome everyone. I'm glad to see you here on day 3 of this wonderful conference. My name is Derek Binkley, and I am a engineering manager at a company that handles localization. We're called Localize, and I am presenting to you today from the state of Wisconsin, which is in the north central section of the U.S. So I'm glad, just excited to be here. And today I'm going to be talking about location-based searching, also known as geospatial searching, and how to add that to your site or your app with Elasticsearch. Let's see here. So there was actually a really great talk on Monday about Elasticsearch and how that works and a lot of the behind the scenes stuff. And that was really great to hear. So I'm just going to give you a quick summary about Elasticsearch, just so we are all on the same page about what we're building. So Elasticsearch is one of the products that is built on the Apache Lucene index, which is a way of indexing text, basically, and other things. For example, today we're going to be seeing how it is used to index geo points. And it's a very familiar interface to us because it uses just RESTful calls. So if you understand basically connecting to any API, you can also connect to Elasticsearch. And there are SDKs in many languages. So like I use JavaScript today, but the last time I gave this talk, I did it in PHP. So there's just a lot of different ways you can interact with it. And this will come up later, but Elasticsearch is read optimized. So that's just something to keep in mind as you're loading data. But I'll explain a little bit more about why that's important in just a little bit. So Elasticsearch is a great tool, but maybe you don't have access to it, or you don't want to learn something new, or you already have geo data in another kind of database. Well, there's just a lot of alternatives. I just did some quick searching and just to find what other databases support this. And basically what I'm talking about today, you can modify the concepts and do it pretty much in any database out there. For example, in Postgres, there's a PostGIS add-on you can put in there. MySQL has spatial and OpenGIS geometry. Apache Solr, which is it's also based on the Lucene index and made by the Apache group, has point and line string, which are very much from the GeoJSON standard, which I'll talk about in a little bit as well. MongoDB has GeoJSON. SQL Server has geometry and geography data types. Couchbase has GeoPoint. Neo4j has spatial functions. Oracle has a whole product, a spatial DB product, which I think is integrated into their main product too, if you pay the right amount of money, but I'm not 100% sure on how that works. So my point here is just that what we're doing here is transferable to lots of other different technologies. So, but the terms will be, as you can see, everybody calls it something slightly different because they want to brand it to their own thing. But the concepts are going to be pretty much the same. So what do we want to build today? Let's see, we want to build something that does geospatial searching, which is, basically taking our geographic data, like where our users are, where certain things are around them, and searching that to find relevancy. So specifically, you're going to see adding some searching text descriptions of particular locations, searching for nearby locations, searching within an area, a particular geometry, and sorting these results by either location or relevancy of the results. And if you put all these things together, you can imagine you can create a very powerful app to do this. Your users out there in the world, you can get access to their location, so you can give them so much like relevant stuff about it if you have the proper data about stored somewhere that says what's nearby them, and just allowing them to connect with that. So yeah, so first we need some data. So let's go, how do we store data in Elasticsearch? Well, Elasticsearch uses it as a JSON document. So we're going to have a document for each piece of data that we're going to be storing. And then we want to index that. This is one term where Elasticsearch is the terms are a little bit different than what you might expect. The index is a grouping of documents with a similar structure. So in my examples today, I called my index places because I load a list of places in Greece that we can search on. And mapping is kind of like, this is what you would think about in like a relational database about your table structure. So the mapping is defining what is contained in your document. And by telling, Elasticsearch will try to figure it out if you don't tell it. But if you have specialized data types like locations, it might not figure it out depending on how well formed all your documents are. So I've found it's better to just tell it what you want. So this is how I defined my, this is how I defined my places. As you can see, I'm running on localhost. I've got this. And like I said, this is RESTful. So I just have to do a put to my places index. And this is creating an index for me called places. And then a mapping. And so I map in the properties. I've got an integer ID. And this is separate from the internal ID that Elasticsearch will assign for its own purposes, which you will have access to as well. So if you've got a location point, I define this as geopoint. In a little bit, I'll get to the other options. And then I've got some text here about like the things and some keywords. Keywords can be thought of as like almost like enumerations, except you don't have to spell out all of the pieces of it, but it's not text that you're searching of. It's more like a lookup field. Like for example, country code could be a good keyword. So let's see. So our data types. Okay, we already talked about text. We could keyword. A geopoint stores just the latitude and the longitude with it. If we wanted to, we could have a geo shape. So for example, I've got geopoints for locations out there, but if you think about like, one of those locations might be like a big park or the zoo or something like that. And if you think about that, you might want to, depending on how you're searching and what the point of your searches are, you might want to define the shape like around the park so that you can get, the boundaries of it versus just picking a point inside and saying, okay, this is what I'm going to base it off of. It all depends on, what you're doing with that. And then there's a bunch of different other formats that we have, long, integer, short, etc. That I won't get into, but, end dates and Booleans and binaries. So the mapping, Elasticsearch has really good documentation. So I'll let you look at that as needed. So let's see here. What we have is, this is some of the data that I have. And these are my lookup fields. So for example, this is from a publicly available source. I got GeoNames database. So they have these, they have this feature type and a feature class, or it might be vice versa, but we'll see when we get into the database. So we're going to be looking for like geographic things or like parks and stuff like that around us for this particular application that we're building today. And so when I said Elasticsearch is meant for reads, searches, you need to think about that when you're loading your data. So they have this bulk write feature. I won't get into it today because I want to get to the geo part of this. But just something to keep in mind, that if you're going to, throw hundreds of thousands of records at it, you want to make sure to like look up the bulk write command. So if you haven't seen an Elasticsearch query, it's going to look just like this. We're going to do a get on our places index, which I created, and tell it, okay, we want to hit the search endpoint. And this just brings back anything kind of in whatever order it feels like. I haven't told it anything about what to match or how to sort it. But I will just give you a quick example of what this looks like, just so you get, yeah. So, oops, actually I don't have that. I'll get back to that in a little bit. But the one thing that I want you to notice here is that this is a get and there is a JSON body. If you read the MDN web docs, they'll kind of recommend don't do this. Don't put a get. But Elasticsearch, since there are, they have a standard, it's very published and you understand it. You don't have to worry about some of these things because they say, well, MDN is saying, some people might not necessarily support this. So if you're like writing your web app, probably don't do this. But if you're building your own product, you can say, yes, Elasticsearch can do it because they have like their own protocol and their own connection, or not protocol, but their own connection. Okay, so here we're going to just do a very basic text search. I'm just going to do a match of, I'm going to say, hey, what's everything named park? And so you can see here, I get a little bit of metadata. It found 43 things. And by the way, what I did for this data set is I loaded in just this geo names. I just took everything in the country of Greece that they had, and I put it in here just to see what it is. So you can see, and then I stored it in I took it out of CSV and I stored it into a JSON into Elasticsearch. So you can see here, this is how I stored my location point. And there's a bunch of different formats for how you store that geo. Sometimes it specifies lat and lom and things like that. But and you can see here, there's actually a lot of things named just park. And you can see here, these are, it scores these results for us, which is really good because, and you can see these are all equivalent because for some reason there's a bunch of, oh yeah, here's something with park in it. It doesn't score quite as high because it's not just park, it's park hotel. So that scoring is its sense of relevancy of those documents. So let's go to like a little bit more advanced query. So if I want to filter on everything that has a feature class of L, you can see here. Let's see, you can do this just by this and say, let's filter. And the one thing that I want to point out here is that the max score is 0. You've got 0 here because what we're doing is we're filtering. So we haven't yet told that we just said, I want this everything with L in it. I'm not really matching on text yet. I'm not really doing like a search. I'm filtering, which is just a good distinction to know as you're building out your application. And now we can combine these two. One way to do that is with this bool query. And I'll just show that real quick here. And now we will get relevancy because what this does is it matches, the term feature class. This is our lookup, and we're only getting things with L in it. I can't remember what else that stands for, but I think it's like landmark or something like that. And so you can see here, we're looking for things with a name of park in it. And so this has park in it. The Olympus National Park. And this natural park. And then you can see it's actually like sorting these again. It tells us our max score. And that score is just the relevancy within that query. So if this one got a 5 and another one got an 8, that doesn't mean that the 5 is any less. You can't compare it beyond searches. It's only within that search. Okay. So yeah, so this is just what I was talking about. The must, which I put in here. This is funny to me. When you say must match, it sounds like this is going to be like a filter as well. But that's actually telling it that I want to search on that. But you only give me stuff that you found it somewhere in there. versus other, there are some fuzzy searches and stuff, and there's just a ton of things you can do with text search, but we want to get to the geo part of this. So I'm going to move on and leave that to you to discover, your own ways to search out your text. So the other thing that I'm going to kind of show here real quickly is the idea of aggregations. This is, I think this comes up a lot in NoSQL databases. MongoDB has this as well. But if you are just used to relational databases, aggregations can be thought of as like a group by. So basically we're saying, okay, I want all the terms, I want the terms of feature class, and then like a unique term. So this will give you a list of all the feature classes in there, as well as a count. So you can see here, it calls it buckets. I think MongoDB does the same thing where they call it buckets. So feature class of P, has this, etc. So now we'll get to what we all came here for, which is learning about the geo searching. So our first thing that we're going to try is let's search in a circle around a point. So for example, you want to know, okay, what's everything within 2 kilometers of like where my user is? Let's see what let's see what that looks like. We are going to. So we get a result here, but you see here, there's no scoring because we didn't do some sort of text search. There's no relevancy. We're just saying, okay, within this circle that has a radius of 2 kilometers, just give me the results. They're not sorted. They're not anything because we didn't tell it anything other than I want to filter. Again, we're doing a filter, so we're not getting relevancy here. We're just saying, okay, this is our circle. So what would happen if we want to add in a little relevancy? Yeah, so this is just like an example here. I just kind of like picked this random point in Athens, I believe, and did this is not to scale. This is not 2 kilometers, but just kind of a rough idea of, we're searching everything in here that is in our database. So now let's add some text to it. So we can do the same thing we did before with our must match. And let's see what that looks like. So must match. I'm just going to say, let's look for something with a church in it. Because I know that this database has lots of like landmarks and things like that. So what does that give us? It tells us, so there. So now it's giving us a score. So it's actually deciding what, how it thinks the relevancy of these things are. So you can see here, there's a lot of church of the, So say, for example, what if we wanted to change this search up a little bit? I saw something mention Athens in there. So what if we just wanted everything within our point that has Athens in the name? Oh, it's actually just that one thing. So here, I'll just switch it to a park just to get something different here. And let's see here. Oh, there's actually no parks in this 2 kilometer radius. Just for fun, before I move on, let's see what happens if we change it to 25. Okay, so the Athens Park Hotel is actually the first thing it found. Radisson Blue Park, so the Park Hotel. Okay, so a lot of, you're seeing here, it's got park in it. And its name, Metropolitan Park. So this is an actual park. So obviously, if we wanted to just get at parks, we could filter on this feature code. But I'll leave that up to your imagination about, what that would look like. So now let's talk about the closest match. This is going to be a little bit different because we want to see, okay, what is closest to our user? This is the latitude and longitude of our user sitting there, standing in kind of the middle of Athens, saying, "Hey, what churches are nearby me? I want to know." So instead of filtering by our distance, now we are going to sort by our distance. And one thing to note here is when you're doing a filter, The filter type is geodistance. When you're sorting, it's underscore geodistance. So that's just a potential kind of place where you could get tripped up. So just note that. And yeah, and so we have our same like location point defined with our latitude and our longitude. And so what have we added? We've changed this to be, so we changed two things. We took out our bool part of the query because we're not querying and then filtering. We're actually, this is like a single query. We're looking for text and then we're sorting those results. So it's a little bit different conceptually, which is why I have to change the syntax a little bit here. And the other things that we've done here is, okay, we order it by ascending. We set our units that it tells us how far away it is in kilometers. And we've set our distance type to arc. The distance type, there are two types. There used to be three, but I think they've split it to two. There used to be arc, sloppy arc, and plane. I think now it's just arc and plane. Those are the only ones I've ever used. Arc is more accurate, but if you have a lot of data, it can slow down your searches because arc is actually like taking into account like the curvature of the Earth. And so there's plane, which kind of flattens stuff out and makes the search faster. So realistically, if you're just searching within a city, like plane will probably get you where you want. But if you're searching like long distances or you're, near the North or South Pole, that's when arc can really get skewed just because of the way mapping works and stuff. So yeah, so that's just kind of important distinction to keep track of. So I'm going to bring this over here and let's see here. We are going to sort by distance. And you can see here, let's see here. Do we have our, oh, that's interesting. Oh yeah, so we actually aren't, instead of scoring it, we are sorting it. So in this search, we've kind of taken away the relevancy and then sorted it by kilometers. So it's telling us how many kilometers away it is, because basically by this sort, we're saying that's the most important thing that I care about right now. So let's see here. And then got to get back to my slides here. And then, okay. So what happens if we want to like let our user like draw a polygon and search within that for whatever reason? We want that to be part of it. Like, they might say, okay, I want to stay in a hotel like in this area. Or I want to visit a church in this area. So what you would do is you would define the points, kind of like the data points here. If you can, oops. If you can see my my cursor here, I'm defining the polygon, and then you can have as many points as you want here. Obviously, if you have a lot of points, it's going to make the searching more complex and potentially slow it down. But this is another way, and the results for this is going to be again, this is a filter, and we're doing a geopolygon in this case, and location point is telling it, okay, what data field in our data are we getting this from? So this is a name that I made up, but these other two are geopolygon and points, the array of points that comes directly from Elasticsearch. So, so yeah, so you're going to get, yeah, so, okay, so we've drawn the map, and now let's think a little bit differently. I'm going to just have another scenario, and I'm not going to show you the examples of this. I'm just going to kind of go through it conceptually here with my slides. One time I worked on a fitness app, and we collected a bunch of things like we were collecting like multiple times per second, timestamps and like the location, as well as like the fitness stuff like heart rate and whatnot. And so what we were able to do is, kind of say, okay, here's where you went on your run today. So we were plotting a lot of these geo points, but we were getting like so much data, you can get this defined. You can get like, 10,000 data points like in a small area if you're not careful. So how do we manage to map that in a kind of a an easy way without sending back like, to our client that's going to like render this on the map. We don't want to send back like 10,000 data points to like, to show like, every thousandth of a second where the person was on their run. So Elasticsearch has something actually to help us with that. It's a geo aggregation. So, but you can imagine, but before I get into that, I can say one problem that I had when I was making this is if we tried to make guesses ourselves about where to like truncate this data, like how often do we poll, and do we do every thousandth, every thousandth data point or something like that? We were starting to get lines like this that kind of, didn't look very accurate because they're like, we know the user didn't actually like go on the grass here and walk through this hotel. So Elasticsearch has this, it's this geoline aggregation. And what that does is it actually will understand the geography of it and kind of make this only give you a certain amount of points so that you can like help you build out this line in an accurate way. So I think that that's a really cool like add-on to our application. And this is what it looks like. So you can see here, in this case, I have this run points, like I'm on my run, here are all the points. So I have this new index that I've created for my new data type. And if you notice here, I've got the filter path of aggregations. So I'm actually, this is an aggregation, not not a specific type of search. So, and I want a line, and I've told it, okay, I've told it, this is my point. It's stored as location, and my sort is by timestamp. So we're actually like sorting by this, so we get the order that the person is in. And this is an extremely useful thing. I mean, you could track like, trucks on their delivery, traffic, this would be useful for like any type of transportation app as well. So, and then it would allow you to bring down your, the amount of data that you are actually mapping and making your things a lot more performant. And I just wanted to point this out. There's also an experimental way in Elasticsearch that helps really aggregate this even more accurately by using what they call a time series. And this is experimental, and I don't really know the exact like things behind the scenes about how they're doing this time series. But what I do know is that it's supposed to expand on like this geoline and give you more accurate results so that you can map that line better. And because it understands like how that's moving over time. But it's still marked as experimental. And they say, well, the interface could change a little bit. So, okay, so we've seen like the building blocks for putting a lot of different geo things into an application via these REST calls with Elasticsearch. So what else could we do? Like, what are some things that you could do? Like, when you take these options back to work, there are different ways to aggregate the data, not just with geoline, but geodistance, geohash, geohex, geotile. So these are actually the distance, kind of makes sense. So aggregating by distance would be, okay, like here's all the things 1 kilometer away, here's all the things 2 kilometers away. And then you can kind of group it like that without having to do that in your code, which is really helpful. And geohash, hex, and tile I won't get into, but these are different ways to split up like map elements so that you can understand where a certain thing should be as you're rendering a graph or a map. Geofencing is another application for this. What geofencing does is kind of like alerting or just understanding if something is within an area or outside of an area. An example of this could be, think of a construction site, and they've got tons of expensive equipment, and a lot of these tools are like something people hold in their hand, but they may cost like tens of thousands of euros for like a small tool. So how do you protect that and know what's happening with those tools? Well, you might have some sort of parameters like a polygon set up for, okay, here's our construction site, and these expensive tools, they have GPS in them, so you can be tracking that, and you can say, hey, I see that this tool is leaving our site every Friday and coming back Sunday. What's going on? Is someone misusing things here? So so the idea of geofencing is a really I could give a whole talk just on that. And just real quick, the last thing I want to point out is you can compare your locations with intersects, disjoint, and within and contains are like the opposites of each other. So this helps you if you have two like geopolygons. You can say, okay, well, where do they intersect? Where does this where does this hotel, is this hotel contained within this park boundary or something like that? So those are some other things that you can do, and just hopefully you can kind of be creative about like what you can do with all of these tools that we talked about today. So we are at time, so I'd like to thank you. I do have a few minutes for questions, and I'm putting my email address up here too. So if anyone has other questions, you can also find me on LinkedIn. So I'd be happy to chat about this, offline at any other later time. I'm going to check and see here if we have any questions in the comments section. Let's see. Okay. Oh yes, my LinkedIn profile. I will get that. I will just post that in the chat here real quick. Okay. There we go. Yeah, in case you want to connect with me. All right. I'll just hang out for another minute here just in case any other questions come up. Oh yeah, you're welcome for just got to thank you for sharing my profile. Okay, sounds good. Well, I don't see any questions, just lots of thank yous. It was a really great pleasure talking to you all today. And yeah, I hope you enjoy the last few presentations of this conference. And it was great seeing you.